question 4. In this questions, we added one more predictor study hours in addition to quantitative test scores that we already have in the simple linear regression in question 3. So we simply added one more predictors. So we have predictors 1 and predictors 2. So we have two predictors. If we have multiple predictors and still want to predict the dependent variable using two independent variable, we need to apply multiple regression analysis. So it's exactly the same as what we did in question 3, but we just added one more predictors, and we also gonna talk about the standardized coefficients over here. We actually report the unstandardized coefficient in question 4, but in question 3, but in question 4 we talk about the standardized coefficients. So let's go to SPSS and then analyze regressions in linear and dependent variable gonna be our statistic test scores, and independent variable we're gonna have two independent variable. Let's move those to the independent variable tab, and then statistics, estimates, and model fit. Then click the OK. Yeah, same as the simple linear regression, we would have four table, and then those three, model summary, ANOVA, and coefficient is the important table that we need to look at. So let's look at that. So first question is, do the model significantly explain the variance in the statistic test scores? This question asks whether the model that we propose having two predictors can significantly explain the variance. So this is the matter of ANOVA, whether it is significantly explained or not. So if it is if the significance level is less than 0.05, that means our regression model having two predictors significantly explain the variance more than zero. I know, more than the random error. So same as the ANOVA, we need to report F values and P values. You know how to report those F values and P values in APA style. I'm not going to talk about this. The model significantly explained because the significance level is less than 0.05. Explain the variance in what? In our dependent variable. What is our dependent variable? Statistics test scores. And then let's look at the second questions. How well the model predict the statistics test scores. Well, this is the matter of the amount of variance that can be explained by the model. So this question, you have to look at the model summary. Which part? Adjusted R-squares. We talk the R-square is a biased measure of effect size. So we report adjusted R-squared. The model explain how much? Actually, point two, point 221, and then simply we multiply with 100 and it would give us 20.1, and the model explained 22.1% because when we multiply with the 100 it gives us percentage of the variance, and the statistic test scores explained by the regression model that we propose. And then let's look at the last questions. Provide the regression coefficients in table 1. This should be table 1. Report the standardized coefficient. I asked you to report standardized coefficients. And then let's look at the standardized coefficient. You need to look at the coefficient table over here. And then the second column is about the standardized coefficient. What we need to report is, the second column is about unstandardized coefficient, but what we need to report is a standardized coefficient. So we usually call the standardized coefficient as beta, and the unstandardized coefficient is B, because beta is a Greek letters, and that when we don't know the parameters, because parameter is about the population, so then we label them in Greek letters. So beta is a standardized coefficient that we um, kind of estimate in population level. So here you we have constant, but we're not going to talk about this. We have two predictors. One is quantitative test scores. The other is the study hours, and then this is the beta for the quantitative test scores. This is the beta for the study hours. As you can see, the unstandardized coefficient for the quantitative score is 0.361, and then for the study hour, it was 1.341, but once we standardize, it looks really huge differences over here. However, if you look at over here, it is not that different. Why this happened? Because the unit of the study hours are not equivalent with the unit of quantitative test scores. This is why sometimes these unstandardized coefficient kind of mislead us to say like there's a huge differences, like study hours makes way much more contribute to statistics test scores. However, the differences is actually the standardized differences is actually 0.114, and that's it. So this is why when we compare the effect sizes or the effect across multiple um, predictors, it's usually better and meaningful to report the standardized coefficient beta. However, sometimes you really want to know how many hours makes those change. Then the standardized measures of study hours really doesn't make sense at all. So in that case, you can look at this unstandardized coefficient. Hey, the person who study 1.5 hours more than others would have better score at statistics test scores, something like that. So you actually can see the extra hours, extra time, then the unit is actually important in this sense. Then we report unstandardized coefficient. However, other than this, I would recommend you to use standardized coefficient. Same as in the question 3, we report t-test values and then significance level for associated each t-test. So in this case, so let's interpret this first. So quantitative test scores, we have 0.24, right? And for the t values, 1.322 is this significant. The effective quantitative test score is significant. No, at point, I would say 20. So it's not significant, right? And then what about study hours? 30 hours, the standardized coefficient is 0.35, and the t value is 1.995, and then p value is 0.06. That's not also not it is not also significant, same as the quantitative test scores, right? But almost close to 0.05, but still not significant. So how we could interpret this finding? One unit change. I changed this word. You have to look at this one. Previously, we say